Hi again. This is our last section for the week. Section 2.3 talks about measures of center. The center is the middle, typically, of the data, but we have three ways to talk about the center of a data. The mean, which is just an average, the median, which is the actual middle, and the mode, the one that happens the most. Now, we have some new notation showing up in this section. Everyone already knows how to calculate a mean. But what might be new is the notation. We use X bar for the sample mean. And we use this Greek letter that kind of looks like a cursive M, but it's called mu. There it is spelt out. And mu would be the population mean. Now, how do you calculate a mean? So typically you see X bar is equal to the sum of all the data values divided by the sample size. So let me say that again. This is the sample mean is found by finding the sum. That's what this symbol right here is, a sigma. The sum of all the x's, sum of all the data values divided by the sample size. Okay, so I'm not going to go through that. You can read that through in your book if you'd like. The median is easy to find if you're in like a stem and leaf, for example. So I have one here where it's just fat grams. In your lunch, you kept up with how many fat grams were in each of your lunches for, I don't know, several days. And so let's take a look at how many data points we do have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let me use my nice manners and put that on our table. Now, the median is truly just the middle value. So I need 6 below and 6 above. And so right here, that 9 is representing the middle because there's 6 values under that 9 and 6 values above that 9. But that 9 represents who? 29. So the median fat grams is 29. You can talk about the min, which was 11, and the max, which was 42. And in the next section, we'll talk about ways to talk about how spread out your data is. The mean, we can add all those values up and divide by 13. And then the mode is the one that you see the most. So you actually have two modes in this problem. You have 11 and you have 30 because they both happen twice. Okay, so what would you do if there was an even number and you needed to find the median? So very simple. I'm going to make this crazy easy. We're only going to have two leaves, and we're going to do this really important data here that I totally made up. And you're going to look at the two middle values. So in this particular case, that would mean this 4 and this 5. And so 14 and 25 are the middle, and we take an average of that. So we would take 39 and divide by 2 to get our median. And most of you guys did this in high school, no problem. You just need a quick refresher. Okay, great. Now, the one that seems to stump everybody in 2.3 is a weighted mean. And so let's look at the notation for a weighted mean. X bar is who? X bar is our sample mean. And then what does this symbol mean? It means to sum up. And so there's an understood parentheses here. You're going to take each data value times its weight and then sum up all those products and then divide by the sum of all the weights. Okay? So most of us have seen a weighted average before. We've just maybe not calculated our own. Most classes are done this way. And so I made up a class that's going to have their homework as 10%, their quizzes are 15, the exams are 60, and the final exam is 15. And then I've given you several values from the student's score. So in order to create the average, I have to come in and take each score times its value. And so 70 and 82 are from the quiz category, so they would be multiplied by 15% as a decimal form. The 70, the 80, and the 90 get multiplied by the homework percentage, which is 10%. And then you only have one test grade, and it's worth 60%. Now, you sum all those up, so that's all in your numerator. And then you divide that by the sum of all, you divide that by the sum of all the weights that you saw. So you used 15% twice, you used 10% 3 times, so instead of writing it 3 times, I'm going to do times 3 because I'm pretty lazy. And then plus the 0.6. So all of that is your denominator. So if you're working this with me, your numerator should be 85.8 and your denominator should end up being 1.2. When I do that division, that will give me the student's current average. And an eyeball check for this is the one that's weighted the most should be influencing the score the most. So she made a 65 on her exam. That was 60% of her grade. So although her other grades were good, that 65 is pulling her average down. So that's how we can do a weighted mean.